Hello everyone, my name is Amal More and welcome to our channel Solution to Blackbook. Now today one of our student has asked us this nice question that what is limit x tends to 0 e raised to 1 by x. But I am not only going to answer you that what is limit x tends to 0 e raised to 1 by x, but I am also going to make you the graph of e raised to 1 by x so that you will exactly understand what is the meaning of limit and the graph of e raised to 1 by x. So let's start. Okay, so limit x tends to 0 is what they have asked us. So first of all, what you will do is you will calculate LHL, which is the left hand limit. So what is left hand limit? Limit x tends to 0 minus e raised to 1 by x. Now what is the meaning of 0 minus? It means x is approaching 0 and it is very close to 0 but on the left hand side. So if you observe the number line, this is 0 and you are approaching 0 from the left hand side, then you will be very close to 0 over here, but you will be a very small number but negative. So observe very carefully. If x is negative and very small, if x is negative and very small, then what will be 1 by x tending to? Observe this very carefully. So it will be 1 by very small negative number. A very small negative number can be termed as very closer to 0. It means it is 1 by 0, tending to 1 by 0. Now tending to 1 by 0 is what? It is infinity, but there is a negative sign, hence it is tending to minus infinity. So when x is very small, it is approaching 0, then what you can say is 1 by x is tending to minus infinity because it is approaching from the left hand side. So this question turns out to be e raised to minus infinity. Now what is e raised to minus infinity? 1 upon e raised to infinity, and e raised to infinity is infinity. So 1 upon infinity is 0. So as you can see, the left hand limit of e raised to 1 by x is nothing but 0. Very well. Now we will try to find out the RHL. So RHL is right hand limit, which is equal to limit x tends to 0 plus e raised to 1 by x. Now x tends to 0 plus means you are approaching 0, you are very close to 0 and you are approaching it from the right hand side. Let us drop a number line. Now see, you are approaching 0 from the right hand side. You are very close to 0, but you are a positive number and you are a very small number. Then what will happen? Let us see. X is very small and x is positive number. So what will be 1 by x? 1 by x will be 1 by positive very small number. So 1 by very small number means it is tending to 1 by 0, and 1 by 0 is nothing but infinity, and there is a positive sign, hence it is tending to positive infinity. Hence the answer will be e raised to positive infinity. Now e raised to infinity, as every one of us know, is infinity. So as you can see, LHL is 0 and RHL is infinity. It means to the left hand side of 0 on the graph, the value of y will be 0, and to the right hand side on the graph of 0, the value of y will be infinity. So there is a difference in the left hand side value and the right hand side value. Hence the limit does not exist. So the answer to this question is limit does not exist. Okay, but I will also like to discuss how to draw the graph of e raised to 1 by x. Now observe very carefully e raised to 1 by x. Now let us think about to the RHS of 0. RHS of 0. What is happening is just to the right of 0, it is e raised to infinity, which is nothing but infinity. But as the value of x will go on increasing, x will go on increasing, the value of 1 by x will go on decreasing, and that is why e raised to 1 by x will also go on decreasing. Okay, so if you did not get this, you will get the derivative approach. Maybe e raised to 1 by x is your fx and calculate f dash x, it will be e raised to 1 by x dot minus 1 by x square. And I am talking about x greater than 0. It means to the right hand side. So to the right hand side, e raised to 1 by x is always positive, x square is always positive. So basically f dash x is less than 0. F dash x is less than 0, it means the function is decreasing. It means to the right hand side of 0, the function is decreasing. So if you are planning to draw the graph would look something like this. This is your 0. The graph is something like this. But what is happening at infinity, that we don't know. When the value of x is infinity, what will be the value of e raised to 1 by x? Let me calculate that. So limit x tends to infinity e raised to 1 by x. Now this is very easy. If x tends to infinity, then 1 by x tends to 0. 1 by infinity is 0. So this will just be e raised to 0, which is equal to 1. It means at infinity, it means at the value of x as infinity, y value is trying to reach what? 1. But it will never be able to reach 1. It will be an asymptote at 1. So this is how the graph looks like. Just to the right hand side of 0, the y value is c infinity, and just to the right side of 0, the value of y is infinity, and at x equal to infinity, the value of y is trying to reach 1. So let me do one thing. I will drop an asymptote like this, which will be a tangent to the graph at infinity. Okay, so this will be a particular tangent to the graph at infinity. It will never be able to reach 1. See, as you can see. Okay, now the left hand side graph is to be maintained. Now as you might recall that LHL was equal to 0, but left hand side derivative should be calculated. Let me, and more than the derivative, I would like to tell you that as the value of x is less than 0 and we are moving to the left hand side, what is going to happen? 1 by x is going to increase, right? 1 by x is going to increase because as you are moving to the left hand side of 0, so the value of x is reducing. The value of x is reducing in the negative sign. Hence 1 by x is increasing. Value of x is reducing. Hence 1 by x is increasing. And that is why e raised to 1 by x is also increasing. See, I will tell you a simple logic behind it. As you move to the left hand side, x decreases. Hence 1 by x increases, hence e raised to 1 by x also increases. Let us go back and see the logic over here. As we move to the right hand side, x increases, 1 by x decreases, hence e raised to 1 by x decreases. And we also understood the calculus part of it. So again over here, I would like to make you understand the calculus part of it. So let me add a page and let us see. Your fx is e raised to 1 by x. Let me calculate f dash x, which will be equal to e raised to 1 by x dot minus 1 by x square. And for x less than 0, this will be positive. This will be positive, right? And you can see that what is exactly happening at x less than 0, as the value of x will be decreasing to the left hand side. As the value of x will be decreasing to the left hand side, you can see the value of f dash x will be what? It will be negative. Okay, so as you can see that the derivative is always you can see is less than 0. Hence the graph is something like this, reducing graph. So what will happen at minus infinity? That we need to understand. So let me say that limit x tends to minus infinity e raised to 1 by x. So as you can see, as x tends to minus infinity, 1 by x tends to 0, because 1 by minus infinity is 0, which will be e raised to 0, which is nothing but 1. Hence as you can see that at just before the 0 on the LHS, the value is trying to approach 0, and the value is increasing like this. As the value of x is decreasing, the value of y is increasing, but it will never reach 1. It can reach 1 only at infinity. Let us see once again. As we saw that f dash x was equal to a negative number less than 0 always for RHS also and for LHS also. See, x value is decreasing and still y value is increasing. That means this is also a reducing function, decreasing function, and over here x value is increasing and y value is decreasing. Hence this is also a reducing function. In short, what I mean to say is e raised to 1 by x is a decreasing function. And see, we have also drawn the graph of it. And as at x equal to 0, you can see that the left hand side limit is just 0 and the right hand side limit is infinity. Hence we can say that the limit of such function e raised to 1 by x definitely does not exist. If you liked this video and if your concept is clear, please hit the like button. Do share this with your friends. Do spread the knowledge, and please do not forget to subscribe to our channel.